Okay, so we have this problem, and this is our given information. We have two triangles, two kind of adjacent triangles. The inner one here with this 52.5-degree angle, and then the 90, and then the outer one, the bigger one, has this also right angle, but it's got a 41.2 angle of elevation here. Then it's got this 168 meters between the two, and our goal is to figure out this height. We're going to need to go through this point down here, and I'm going to first start by setting up some equations. So this inner angle, this is the tangent of 52.5 equals h over x. Then on the outer, the whole one, the tangent of 41.2 equals h over 168.x. Now, we went over how to solve this algebraically, but we can also do this on our graphing calculators. To do that, I want to solve both for the value x. The reason I want to solve for x is I'm trying to figure out h, so I want that in my problem. So I'm going to solve this upper one for h, and this is actually pretty easy. This is over 1. I can kind of flip things around if I want, or I can write it out, whichever one's to go. So this is going to be x tangent 52.5 equals h, and then I divide, so h x equals tangent of 52.5, and h is on the top. Okay, so let me rewrite this over here. I got carried away. Tangent 52.5. Okay, so this is my first equation. My second equation is a little bit more work, but not too bad. I'm going to first multiply out, so 168 plus x tangent 41.2 equals h. Okay, so I just multiplied by that bottom to get it right. Remember, I'm solving for x, so to do that, I'm going to distribute over here. 168 tangent 41.2 plus x tangent 41.2 equals h. So an x tangent 41.2 equals h minus 168 tangent 41.2. So x equals h minus 168 tangent 41.2 all over the tangent of 41.2. Okay, these are my two equations. Now I have to put them into my graphing calculator to make this work. So let me pull up my graphing calculator. So I'm going to start with this awful looking one. Now, first of all, do make sure, usually I would graph in radians, but we're not there yet, and these are all in degrees, so make sure you're in degrees. I'm going to put in my first one. I'm going to use lots of parentheses. Now, I'm going to replace h with x here because obviously I'm using y and x. I'm graphing. So this h is my x. This is what I'm looking for. I should have used something else for x, but okay. So x minus 168 times tangent of 41.2, end parenthesis there, end parenthesis, end parenthesis. Okay, divided by tangent 41.2, end parenthesis, end parenthesis. Okay, then I'm going to do my second one. So I'm going to go up here, and I had x divided by tangent of 52.5. One more. Okay, then I'm going to hit graph. And it's going to think about it, and it's probably not going to show much of anything because I need to reset my windows. Oh, I'm getting one. I don't think I'm going to get both on the first go, though. Let's see what I get. No, so I'm going to reset my window. This is in the hundreds. That's 168 right there. I don't want a 10 by 10 window, so I'm going to change this to 500 by 500. And honestly, I would be guessing here if I hadn't already done. I'm going to count by 20s. My goal is just to make it a lot bigger. And I would kind of make it bigger. You can also just use your zoom out. But a lot of times I find it's easier just to reset the window, and then I'm going to regraph it. So your goal is, okay, I'm looking at this. I know my answers are probably going to be in the hundreds based on I already have one in the 200 range. So I'm thinking that. I'm like, okay, let's get this fairly far out. Okay. Now, what I want to know is I want to know when these two lines intersect. I'm solving a system the same way we did the other problems. The difference is that I'm solving the system graphically. That means these two have to intersect. So I'm going to go to second trace. It's my calc menu. I'm going to hit intersect. And first curve, enter. Second curve, enter. Guess, tell it to enter. If you had 3 or 4 things graphed here, this would be a bigger deal, but really just hit enter 3 times. So I'm looking for my x value because that's what I replace h with. So my intersection is at 448. So my answer, because all this was rounded to, this is rounded to the nearest meter, so I'm going to round to the nearest meter, 448 meters is the height of this, of h here. So you can see that worked pretty smoothly. The biggest thing with this is you will have to kind of play with the windows, and they're really kind of a pain in the butt to put in at times. You could have done this, the way I did this in the lecture notes, the first one is I found it easier to solve for x and then turn around and use x. You could have done that here, found the x, then taken that value and plugged it in to find h as well. So you could have, done part of it on the graph and then part of it algebraically if you didn't want these quite messy of formulas. But it does work, and this is another method for getting to your answer on some of these applications.